So the next part of Module 9, Lesson 9.5, we are going to be working on probability of compound events. And our learning target, I can use organized lists, tables, or tree diagrams to find the sample space and probability of a compound event. The vocabulary that we will be learning in this, we have compound event, theoretical probability of a compound event, and tree diagrams. Okay, so we have talked about simple events, but now we are talking about compound events. And just like with simple events, the sample space for a compound event is the set of all possible outcomes. So let's say I roll a number cube with sides 1 through 6. Okay, 1 to 6. And then I toss a coin. Okay, I toss a coin, and I know that in a coin, what are my outcomes? I have two outcomes, right? So I have either heads or I have tails when I am tossing a coin, heads or tails. So that is two outcomes here. And in this one, 1 through 6, these are my number cube. So I have 1, 2, 3, 4, 5, 6. So that's 6 outcomes here. All right. So we are now doing a combination of the two. That's why it is called compound. Okay. So if I'm looking at this, rolling a number cube labeled 1 through 6, followed by tossing a coin, is an example of a compound event. And the compound event consists of the two simple events of rolling a number cube and tossing a coin. To find the sample space of a compound event, first find the sample space of each simple event. So that's what I just did. First find the sample space. So 1, 2, 3, 4, 5, 6, 6 outcomes here, and heads or tails, that is 2 outcomes here. So that's the first step. All right. Now, next we can create an organized list, such as a table or a tree diagram, to find the sample space of this compound event. So I'm going to go ahead first create a table. And so in order to find my outcomes, okay, so I'm just going to create a table. I'm going to show you the table method and the tree diagram method. So we have the number cube, okay, and then when I am tossing the coin, so the coin toss, and then the result. So I'm going to make 3 different columns. Okay, now when I'm tossing the number cube, what are my outcomes? I have 6 outcomes. Okay, so I am going to do this: 1, 2, 3, 4, 5, and 6. So this is 1, 2, 3, 4, 5, 6. Okay, and when I'm tossing a coin, what am I getting? I'm going to split this: heads or tails. Same thing here. I'm just going to put H for heads and T for tails. H for heads, T for tails. Heads, tail. Heads, tail. Heads and tail over here. Okay, so these are the different options that I can have when I am tossing a coin after tossing a number cube. And so what are my results? I have over here, I have 1 head and for 1 tails, 2 heads, 2 tails, 3 heads, 3 tails, 4 heads, 4 tails, 5 heads, 5 tails, 6 heads, 6 tails. So when I'm looking at this, these are all the different outcomes that I can have. So when I look at this, how many outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 outcomes total. Okay? Now, this is by making a list. I can also make a tree diagram. Okay, so tree diagram that can be used to organize the possible outcomes of tossing a coin first, followed by rolling a numbered cube. So if I have coin, I'm going to put coin first. I'm making a tree diagram now. And this was list, okay, in a table. And so I have coins, and in the coin, and then I have number cubes. And then I have the outcomes. And then I have the outcomes. Okay, so for coin, I have either heads or I have tails. Those are the two options that I have, heads or tails. Okay, now from the heads, I can get, if I'm rolling the number cube, I can get, what are my options for the number cube? I have 1, 2, 3, 4, 5, and 6, right? Same thing when I am rolling, when I'm tossing the coin, I can also get, for the number cube, for the tails, I can get 1, 2, 3, 4, 5, and 6. And so now I can look at what are my outcomes. I can have over here, I can have heads 1, I can have heads 2, heads 3, heads 4, heads 5, heads 6. Right? And then here I can have tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. So when I'm looking at this now, I can see that I have 6 of heads, I have 6 of tails. Total outcomes is going to give me 12 as my answer. Okay, so regardless of the order of events, whether I put the number cube first or if I put the coin first, it doesn't matter. I am still going to end up with 12 different outcomes. Okay, so regardless of the order of events, the sample space in the compound event consists of 12 different outcomes. All right, now here is a really good way for you to know how many outcomes there are. The best thing to do is look, I have taken how many options are there for the number cube. I have 6 outcomes. Okay, so I'm going to take 6. How many options are there for the coin? Either heads or tails. So that's 2 outcomes. If I multiply those 2, what is 6 times 2? 12. Look. So this is a great way to check your work. Of course, you've got to know how to make the tree diagram. You've got to know how to do the table. But just by looking at that, you should know that there should be 12 different options that are possible with this compound event. All right. So let's do an example. And I am going to quickly erase this. Okay. So my question is, if I suppose a penny and a nickel are tossed, okay? So a penny is tossed and a nickel is tossed. All right. What is the sample space of possible outcomes? So when I'm looking at each coin, whether it's a penny, what can I get? I can get heads or tails. With the nickel also, I can get heads or tails. So how many options is this? This is 2 options and this is 2 options too. So if you think of the shortcut of calculation, before I make the tree diagram, before I make the list, I know that I have 2 for penny and I have 2 options for nickel. What is 2 times 2? 4. Okay, so if I do 2 times 2, I know that I'm going to have 4 different options over here. Okay, so or the 4 different outcomes would be a better choice. Options meaning your outcomes. That's what I am going to be getting. Okay, so let's use an organized list really quick. So once again, I have my outcomes. Okay, and then I'm going to go ahead, make the list like I had done earlier. I'm going to have penny and nickel. You can put either, it doesn't matter first. So I have penny, I have nickel, and results. Okay, now in penny, I have what? I have head and I have tail. Right? Either I can flip heads or I can, what do you call it? Flip and then I can toss and I can get tails. Okay, now when I am doing this one, let's do this. In the nickel, I can also get heads or tails. Same thing here. I can get heads or tails. Those are the 2 options. So now when I look at this, what are my results? I'm going to have in the first one, I'm going to have heads, heads. Okay, heads and heads. Or I'm going to have heads and tail. Okay, then if I do this, I'm going to have tails and then heads, or tails and tails. So as you can see again, we have 4 different possible outcomes over here. If I am going to use a tree diagram, okay, so this was a table, which is an organized list. The first one was the table or an organized list. And the second one is a tree diagram. Okay, so in the tree diagram, I'm going to put again penny, nickel, and outcomes. All right, so penny is what? Heads and tails. We have heads and we have tails. From this, I can get heads or tails with the nickel, right? Heads or tails. Same thing here. I can get heads or tails. And my different outcomes here, heads, 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 tail, tail, heads, or tail, tail. Okay, so using either method, there are 4 possible outcomes in the sample space. Okay, now I'm just going to give you an example. I'm going to take you over here. So your math teacher owns 3 pairs of pants, 3 pairs of shoes. He owns a pair of gray pants, green pants, blue pants. He owns black shoes, brown shoes, tan shoes. If he randomly chooses 1 pair of pants and 1 pair of shoes, what is the sample space of possible combinations of pants and shoes that he could wear on a typical school day? Okay, so if I'm looking at that, what do I need to be doing? I am just looking at how many pairs of pants are there. I have 3 pairs and 3 pairs of shoes. Okay, so what is 3 times 3? I'm going to get 9. All right, and so that is basically going to be the number of outcomes that I have. And then if I'm making a tree diagram, you can pair off the shoes and the pants. Okay, so if I do over here, okay, so I can do shoes here, I can do pants, and I can do outcomes. I'm just going to make a tree diagram really quick. So let's see, what color is this? Black shoes, black, brown, and tan shoes. Okay, with these he can wear three different pairs of pants to pair them. Okay, so he can wear gray, and green or blue. Same thing with the brown. Gray, green, and blue. And same thing with the tan. Gray, green, and blue. Okay, and so when I look at the outcomes, I can do black and gray. I can do black and green. I can do black and blue. Over here, I can do brown and gray, brown and green, brown and blue. And over here, tan and gray, and tan and green, and tan and blue, tan and blue. So look at all the combinations that we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is basically making a tree diagram of that. But as I was telling you earlier, if I looked at 3 pairs of shoes, I looked at how many pairs of pants? 3 pairs of pants. And I know the outcome would be what? It would be this 3 times this 3, which would give me 9 different outcomes. So this is a really good way to check your work as to how many outcomes there should be overall. Okay, so let's go back here and we take you here, do another problem. Okay, so let's say I'm going to find the sample space of compound events again. A pizza shop sells pizzas. Okay. All right. So a pizza shop sells pizzas with pan or thin crust. Okay, pan or thin crust. How many options are these? These are two of these. Okay, so these are 2 different outcomes. And it sells red or white sauce. Red or white sauce. So that is 2 again. Okay, so we have 2 outcomes here because that's what we're doing first. 2 outcomes here. And then we have the toppings, which would be pepperoni, mushroom, or plain cheese. Pepperoni, mushroom, or plain cheese. So that is 3 different outcomes here. All right. Now, how many possible outcomes are in the sample space for a randomly chosen type of pizza? So think about what I said, which is a really quick way to do calculations. I'm going to look at the simple events. So this one here, I have 2 outcomes. Then the different sauces, I have 2 outcomes. The different toppings, I have 3 outcomes. So if I do 2 times 2 times 3, it will tell me how many overall different outcomes I can have. 2 times 2 is 4, 4 times 3 is 12. So I should be having a total of 12 different outcomes. Okay, now let's go ahead. If I am going to create that, in an organized list, such as a table. In a table, I'm going to have my outcomes. Okay, and my outcomes, first let me put the crust, because this is what we're talking about. All right, we'll talk about the different sauces. And then we'll talk about the different toppings. And then the results. And then the results, okay? So I'm just going to go ahead and do this so you can see what I'm doing. For crust, I have pan and I have tin, okay? So for the crust, I have pan and I have tin. All right, then I have the sauce. I have over here for pan, I can have the red or the white sauce. Same thing here. For the thin crust, I can do red or white sauce. Then for the toppings, for each of them, I'm going to have 3 different options. Okay, so for the red, I can have, what are my 3 options over here? I have pepperoni, I have mushroom, or I have cheese. Same thing here. I can do white sauce with either pepperoni or mushroom or cheese. Or I can do thin with the red, and I can have pepperoni, mushroom, or cheese. I can do thin with the white sauce with pepperoni, mushroom, or cheese. And so when I look at my different options, here are all the options that I can have. All right, so I can have pan crust with a red sauce with pepperoni. So pan, red, pepperoni. I can have pan, red, mushroom. Pan, red, mushroom. Pan, red, cheese. Then I can have pan, white, pepperoni. Pan, white, mushroom. Pan, white, and cheese. Then let's look at this. Thin. Thin, red, pepperoni. Thin, red, mushroom. Thin, red, cheese. And then thin, white, pepperoni. Thin, white, mushroom. Thin, white, cheese. So these are all my results, and I have just put this in the form of a table like this. And so I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 different outcomes that we were discussing earlier. Okay. This can also be shown as a tree diagram in the same way that I would actually, I'm just going to create it on the top. So you can see what a tree diagram looks like in this case. All right, so I'm going to put crust. So this is my tree diagram. I'm going to have my crust. I'm going to have my sauce. Okay, I'm going to have the topping and outcomes. Okay, so for the crust, I have pan or I have thin. Now from here, I'm going to get the red or white, right? Red or white sauce. So I have red or I have white. I have red or white. Then from each of those, I'm going to have 3 different toppings. Okay, pepperoni, mushroom, cheese. Pepperoni, mushroom, cheese. Pepperoni, mushroom, cheese. Pepperoni, mushroom, cheese. Okay, And then all my outcomes are going to look exactly like the table. Okay, so pepperoni, pan, red, and I have over here pepperoni, pan, red, mushroom, pan, red, cheese, and then this continues. So it's going to look exactly like this. All right, so PWP, PW mushroom, pan, W cheese, and then I have thin, red, and I have pepperoni, thin red mushroom, thin red cheese, thin white pepperoni, thin white mushroom, thin white cheese. So look, it looks exactly the same thing. Only thing this is as a table, that's a tree diagram. So we have pan red pepperoni, pan red mushroom, pan red cheese, pan white pepperoni, pan white mushroom, pan white cheese. So that's how we are making a tree diagram. But as I had shown you earlier, we had two of these, right? We had two of these. We had three of these. And so my outcomes would be 2 times 2, 4 times 3, which would be 12 different outcomes overall. Okay, so that's a really quick way to do the calculations. Let's talk about theoretical probability of compound events. And when conducting a probability experiment, the theoretical probability of a compound event is the ratio of the number of possible favorable outcomes to the number of total possible outcomes in the sample space. Okay, so we go ahead and quickly write that ratio out so that you know what I'm talking about. Okay, so if I'm talking about the theoretical probability of an event, is going to be the ratio of number of favorable outcomes, number of favorable outcomes over my total number of outcomes. Total number of outcomes. So it's got to be a ratio written like this. All right. So if a coin is tossed, let's look at this. A coin is tossed, then a number cube labeled 1 through 6 is rolled. Okay. Coin is tossed and number cube 1 through 6 is rolled. So these are my compound events. So if I am calculating theoretical probability, okay, so if I'm going to be calculate theoretical probability of a compound event, we are going to look at, what did I say? In a coin, we just have what? 2 outcomes, because we have heads or we have tails, right? Heads or tails. So therefore, we have 2 outcomes here. We have how many here? We have 6 outcomes here. So look at what it's saying. Number of favorable outcomes over total number of outcomes. So a coin is tossed, then a number cube labeled 1 through 6 is rolled. And then we are going to talk about how many possible outcomes are there. And I've told you it's going to be 2 times 6, which is 12 total outcomes. And you can show this with a tree diagram like we had already discussed. You can have the coin over here, heads, tails. We can have the number cube. Okay, and so then here we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I'm just showing you. And so you could have heads 1, you could have you know, heads 2, heads 3, heads 4, heads 5, heads 6, etc. Okay, so now let's talk about what is the tree diagram. Shows the sample space and identifies the outcome of tossing tails. So let's talk about what happens when I toss tails by followed by rolling a 6. Okay, so my question again, a coin is tossed, then a number cube labeled 1 through 6 is rolled. The tree diagram here shows the sample space. And let's see, we are going to identify the outcome of tossing tails followed by rolling a 6. Okay, so let's look at, is this tails? No, so this is not going to affect us. Is tails here? Yes, so we have tails here and followed by 6. So look what I just circled. So we have tails followed by 6. What is the possibility of that? So first, of course, we are going to do what is the total number of outcomes, which is 12. Okay, and then we're talking about outcomes with tails and a 6. With tails and a 6 over total possible outcomes. Total possible outcomes. So as you can see how I drew this out, we have tails followed by 6 is 1. That is one outcome possible, and total possible outcomes is what? 12. So this would be my theoretical probability of tossing tails followed by rolling a 6 is 1/12. Okay, now let's talk about finding probabilities of compound events, and we are going to say 2 number cubes. Okay. All right, so 2 number cubes, each labeled 1 through 6, are rolled. Okay, so this is number cube 1 and this is number cube 2. Okay, number cube, and then we have 1 through 6, we have 1 through 6. All right, now what is the total number of outcomes that I can have? So this has 6 outcomes because you can roll 1, 2, 3, 4, 5, or 6. Same thing with the second number cube. I have 6 different outcomes. So for total number of outcomes, total outcomes, okay, is going to be 6 times 6, and that should be 36 outcomes overall. That's my total. Okay, now it's saying what is the probability of rolling a sum of 9? Probability of rolling a sum of 9. Okay, so I'm just going to show you by listing it. I'm going to make a table. Let's say this is roll 1. I'm going to put roll 2 up. Okay, to make a table. All right, and in roll 1, I have 6 possible outcomes. So 1, 2, 3, 4, 5, and 6. Okay, so write that here. 6 outcomes, 5 and 6. And in roll 2 also, I have 6 outcomes. So 1, 2, 3, 4, 5, and 6 different outcomes here. All right, whether it's roll 1 or roll 2, I have 6 different outcomes. Now, let's look at these different pairs that I have when I'm rolling. I can get what? I can get 1 and 1. I can get 1 and 2. Okay, do you see what I'm doing? 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6. Okay, and then same thing here, 2 and 1, 2 and 2, 2 and 3. So I'm just going to go ahead and do this, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1. Okay, and then here I have 2 and 2, 3 and 2, 4 and 2. So I'm just like making these pairs, 5 and 2, 6 and 2. And then here I get, what do I have over here? I have 2 and 3, 3 and 3, 4 and 3, 5 and 3, 6 and 3. Okay, this 2 and 4, 3 and 4, 4 and 4, 5 and 4, 6 and 4, 2 and 5, 3, 5, 4, 5, 5, 5, 6, 5, 2, 6, 3, 6, 4, 6, 5, 6, and 6 and 6. Okay, so once I put over this, look what it's saying. Find the probability of rolling a sum of 9. So let's start looking at sum of 9. 1 plus 1 is definitely not 9. 1 plus 6 is not 9. 2 plus 6 is 8. What is 3 plus 6? So here's a sum of 9. Okay, and then 4 plus 6 is 10, but 4 plus 5 is 9. 5 plus 5 is 10, but 5 plus 4 is 9. So look at the pattern. And then I have 6 plus 3 is 9. All right, so the total number of outcomes, that's what we're trying to find. Probability of a sum of 9. Sum of 9 will be equal to number of outcomes with sum of 9 divided by, or the ratio, sorry, and the fraction line is the actually nothing but division, but we are going to write it as a ratio, the number of outcomes with sum of 9. How many had sum of 9? 1, 2, 3, 4. 4 out of total outcomes was how much? 6 times 6, and I got 36. So 4 over 36 is my ratio, and then I'm going to simplify that. So if I divide by 4 and I divide by 4, I get 1/9 is my ratio. 1 to 9 is my ratio. And if I change this to a percent, it will be about 11.1%. 11.1%. All right. We can do one more question. And this is going to be my last question. 2 coins are tossed and a number cube labeled 1 through 6 is rolled. Okay, so 2 coins are tossed and a number cube labeled 1 through 6 is rolled. So now we have 3 things going on. What is the probability of tossing heads at least once and rolling an even number? Okay, so let's look at this. So let's go ahead. I'm going to write down what the outcomes are. There are 2 coins are tossed. So we have, either you have heads or you have tails. So I'm just going to make a tree diagram. I have heads on the first coin and I have tails on the second coin because we have 2 coins that are tossed. All right. And then after that, I have a number cube, 1 through 6. Number cube, 1 through 6. So if I'm tossing the coins, let's look at the outcomes. Okay. So over here in the first coin, I have 2 outcomes. In the second coin, also I have 2 outcomes. In the number cube, I have 6 outcomes. So if I do 2 times 2 times 6, think about it. 2 times 2 is 4, and 4 times 6, I should have a total of 24 outcomes. Total of 24 outcomes. Okay, now let's go ahead, quickly make a tree diagram just so that you can see. We're talking about we have heads and we have tails. And then let's look at, so this was the first coin. Okay, first coin, and then the second coin, and then we have the number cube, and then the outcomes. Then we have the outcomes. Okay, so for the first coin, when I'm doing, what do I get? I get over here again, heads or tails. Heads or tails. Right? Now, let's look at the number cubes now. From these heads, I can have 1, 2, 3, 4, 5, 6. From the tails, 1, 2, 3, 4, 5, 6. From here, 1, 2, 3, 4, 5, 6. From here, 1, 2, 3, 4, 5, 6. Okay? So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, these are all the outcomes. Now, so in the first, this is like heads and heads. Okay, so all of this is heads, heads 1, heads, heads 2, heads, heads 3, heads, heads 4. So that's what I'm getting as my outcomes over here. Okay, heads, heads 1, heads, heads 2, heads, heads 3, heads, heads 4, heads, heads 5, heads, heads, and 6. In this one, I'm getting heads, tails, 1. So again, we'll have 1, 2, 3, 4, 5, 6. Heads, tails, 1. Heads, tails, 2. Heads, tails, 3. Heads, tails, 4. Heads, tails, 5. Heads, tails, 6. Okay? Now, in the next one, we are going to get tails, heads, 1, 2, 3, 4, 5, 6. But here is the thing. Okay, so I'm going to go write it out again, and then we're going to talk about the outcomes, which are favorable, which are not favorable. Okay, so again over here I have my tails. Now we have tails, heads 1, tails, heads 1, tails, heads 2, tails, heads 3, tails, heads 4, tails, heads 5, and tails, heads 6. And in this one I have tails, tails 1, tails, tails 2, tails, tails 3, tails, tails 4, tails, tails 5, and tails, tails 6. So as we can see, 4 times 6, we can already see we have 24. Okay, now what we are looking for is, what is the probability of tossing heads at least once and rolling an even number? Okay, so tossing heads once and then rolling an even number. So if I'm looking at this, are we tossing heads once? Yes, we are, because over here we are tossing heads 2 times. Here we are tossing heads 1 time. We are tossing heads 1 time. This part does not even relate because there is no heads, there's only tails over there. Okay, so we cannot use that. These outcomes are not favorable because heads are not tossed. So all of these tails ones we can forget about. Okay, now it said once again we've got to do heads at least once and an even number. So look, even, heads and even, heads and even, heads and even. We have heads here, 2, 4, 6. All right, so here we have a heads, 2, 4, this is a 6. Okay, so 6, and then the last option does not is not included because the outcomes are not favorable. So if I look at this, I'm going to have 9 possible outcomes that are favorable. Okay, so here is my probability of calculations for this. Okay, so probability for heads which is greater than equal to 1 and even. So I should have heads greater than equal to 1. Okay, and it is even, and an even number. So this is going to be there are 9 out of 24 possible outcomes. So we have 9 out of total outcomes, which is 24. Okay, so now when I look at this, I can simplify this ratio. And if I divide by 3, I get 3 out of 8. And then I can change this to a percent. And when I change this to a percent, I'm going to get 37.5%. Because if I divide 3 by 8, I'm going to get 375 thousandths. Okay, so this, I can get this, or as a fraction or a ratio, it is 3 to 8. Okay, and so that's how we find the probability of this. So in short, once again, when conducting a probability experiment, the theoretical probability of a compound event is the ratio of the number of possible favorable outcomes to the number of total possible outcomes in the sample space. And so the compound events, because it's more than one simple event that is happening at the same time. Like we had talked about, you can roll number cube, and we can toss a coin at the same time and another coin. So then we have to see what is going to be the outcome of that overall. Okay, so that concludes our lesson for probability of compound events, which would be lesson 9.5. Have a fabulous day.